The Triassic period, a time of profound transformation and strange wonders, marked the beginning of the Mesozoic era. Spanning from approximately 251 to 199 million years ago, it was a period unlike any other in Earth's history. It began in the ashes of the greatest mass extinction event the planet has ever known and ended with another major extinction, serving as a dynamic and volatile crucible for life. This era was defined by recovery, experimentation, and the rise of a new lineage of reptiles that would eventually inherit the Earth. But before the famous dinosaurs could dominate, the Triassic world was home to a spectacular array of creatures so bizarre and alien they seem almost mythical. From armored reptiles that looked like armored boars to long-necked creatures that defied the laws of anatomy, the animals of the Triassic were shaped by a series of monumental events. To understand why they were so strange, we must first look to the monumental catastrophes that preceded them and the unique world they inhabited. The Great Dying, the scourge of a planet. The Triassic began not with a bang, but with a silent, suffocating catastrophe. It was ushered in by the Permian-Triassic extinction event, an apocalyptic upheaval that is often referred to as the Great Dying. Occurring roughly 252 million years ago, this event was the most severe extinction in Earth's history, wiping out an estimated 96% of all marine species and 70% of terrestrial vertebrate species. The world that emerged from this cataclysm was a barren, empty canvas, an evolutionary vacuum ripe for new life to fill. The primary cause of this planetary upheaval was not an asteroid impact, but a series of colossal volcanic eruptions in what is now Siberia. These eruptions formed the Siberian Traps, a massive, large igneous province. Over a period that spanned hundreds of thousands to a million years, an estimated 1 to 4 million cubic miles of lava erupted and flowed across the land. This scale of volcanism is almost incomprehensible. If that volume of lava were spread evenly over the entire landmass of the United States, it would bury it under a layer of rock nearly 200 feet deep. The immediate and long-term effects of this volcanism were devastating. The eruptions didn't just produce lava, they spewed colossal amounts of greenhouse gases like carbon dioxide, CO2, as well as sulfur dioxide, SO2, and other toxic compounds into the atmosphere. The SO2 initially caused a temporary volcanic winter by forming reflective aerosols that blocked out sunlight, causing a sharp but brief drop in global temperatures. However, this was quickly overshadowed by the long-term effects of the CO2. The massive influx of this greenhouse gas into the atmosphere triggered runaway global warming. The planet's average temperature soared, making vast swaths of the land uninhabitable. The oceans, the cradles of life, suffered even more. The rising atmospheric CO2 was absorbed by seawater, leading to ocean acidification. This made it nearly impossible for marine organisms like corals and shelled creatures to build their calcium carbonate structures. The global warming also led to a significant decrease in the oxygen content of the oceans, a phenomenon known as ocean anoxia. Anoxia created vast, dead zones where most life could not survive. In a world with a superheated atmosphere and suffocating, acidic, and oxygen-depleted oceans, the vast majority of life perished. On land, the casualties were immense. The dominant vertebrates of the Permian, a group of mammal-like reptiles called synapsids, which included the famous Dimetrodon and the tough Gorgonopsids, were decimated. The iconic trilobites, which had been a staple of the seas for hundreds of millions of years, vanished forever. The Permian-Triassic boundary represents the most significant break in the fossil record, a stark reminder of a world that was utterly remade by a geological catastrophe. Pangaea, a continent of extremes. The survivors of the Great Dying emerged into a world that was radically different from the one their ancestors knew. The Triassic world was dominated by the supercontinent of Pangaea. All of Earth's major land masses were joined together, creating a singular, immense continent that stretched from pole to pole. This unique geography had a profound impact on global climate and, in turn, on the evolution of Triassic life. Pangaea's vast size meant that its interior regions were far from the moderating influence of any ocean. This resulted in a hyper-arid, desert-like climate across much of the supercontinent. Rain-bearing clouds, which formed over the coastlines, struggled to penetrate the deep interior, creating conditions similar to today's Sahara or Gobi deserts, but on a planetary scale. The lack of a major coastline also meant that global ocean currents were different, contributing to a hotter, less stable global climate. Seasons were likely extreme, with scorching summers and potentially cold, though dry winters. This hot and arid environment acted as a powerful evolutionary filter. It strongly favored certain types of animals and disfavored others. Reptiles, with their scaly, waterproof skin and specialized kidneys for conserving water, were perfectly adapted to this brutal climate. They could survive in environments that would have been lethal for most amphibians, who required moisture to breathe through their skin. Mammal-like synapsids, while they possessed some adaptations for water retention, were still recovering and found themselves outcompete in many of the newly available niches. The Pangaean world was a crucible of evolution, where the survivors of the Permian extinction were subject to intense selective pressures. This harsh environment was one of the key reasons that reptiles, particularly a new group called the Archosaurs, came to dominate the Triassic. They were not just the most successful survivors, they were the best equipped to exploit the opportunities presented by this new, unforgiving world. Adaptive radiation, the engine of Triassic bizarreness. With the vast majority of life extinguished, the survivors found themselves in a world full of empty ecological niches. An ecological niche is essentially the role and position a species has in its environment, including its place in the food web, its habitat, and its interactions with other species. In the post-Permian world, almost all of these roles were vacant. This created the perfect conditions for a powerful evolutionary process known as adaptive radiation. Adaptive radiation is the rapid diversification of a single ancestral species into a multitude of new species, each adapted to fill a different ecological niche. Think of it like a group of architects and builders being given an empty city. Each one designs and builds a different type of building, a tall skyscraper, a sprawling factory, a compact house, to fill the various needs of the population. In the biological world, the architects were the surviving lineages and the buildings were the new species with their specialized adaptations. The most successful builders were the Archosaurs. They were a diverse group of reptiles that included the ancestors of modern crocodiles, pterosaurs, flying reptiles, and dinosaurs. They had a number of key evolutionary innovations that allowed them to flourish. One of the most important was their efficient upright stance, which allowed them to move more quickly and for longer periods. They also possessed unique respiratory systems, with specialized air sacs that helped them breathe more efficiently than most other vertebrates. These advantages, combined with the empty niches, allowed them to undergo a spectacular adaptive radiation. This is the central reason why the animals of the Triassic looked so strange. Evolution was essentially in an experimental phase. Without any pre-existing dominant competitors, surviving lineages had the freedom to explore and adapt to a wide range of lifestyles. The result was a menagerie of oddball creatures, each a unique solution to a particular environmental challenge. A gallery of the weird and wonderful. The Triassic period produced some of the most fantastical animals to ever walk the earth. They were the products of adaptive radiation, filling niches from top predator to armored herbivore, from tree-climbing insectivore to semi-aquatic ambush hunter. Let's explore some of these extraordinary creatures. The Aetosaur. Armored herbivores. The Aetosaur were a group of armored reptiles that were abundant in the late Triassic. Superficially, they might resemble armored crocodiles, but they were actually herbivores. Their entire body, from their heads to their long tails, was covered in a dense mosaic of bony plates called osteoderms, creating a suit of impenetrable armor. They had a pig-like snout, which they likely used to root for tubers and other plants. The Aetosaur's body plan was a direct response to a world where terrestrial herbivory was a newly available and highly successful niche. They were a perfect example of a successful, but ultimately short-lived, evolutionary experiment. The Phytosaurs, crocodiles that weren't. The phytosaurs provide a stunning example of convergent evolution, the process where unrelated organisms independently evolve similar traits to adapt to similar environments. In appearance and lifestyle, phytosaurs were almost indistinguishable from modern crocodiles. They had long snouts, powerful tails, and an amphibious lifestyle, preying on fish and other animals along the water's edge. However, their relationship to crocodiles was distant. A key difference was the position of their nostrils, which were located on a raised mound in front of their eyes rather than at the tip of their snouts. This subtle anatomical difference reveals a separate evolutionary lineage. The phytosaurs filled the niche of a semi-aquatic ambush predator with incredible success, but they were not true crocodiles. They were a distinct archosaur lineage that simply evolved the same body plan. The ichthyosaurs, reptiles of the deep. Not all of the strange creatures were land dwellers. The ichthyosaurs, meaning fish lizards, were a group of marine reptiles that achieved an astonishing degree of aquatic adaptation. Their sleek, streamlined bodies, dorsal fins, and tail flukes made them look eerily similar to modern dolphins and tuna. They were an apex predator of the Triassic oceans, hunting fish and cephalopods. The fact that a reptile could evolve a body plan so perfectly suited for the marine environment, entirely independent of fish or cetacean evolution, is a testament to the power of adaptive radiation and convergent evolution. The Trypanosaurs, the bizarre tree climbers. Perhaps the most alien-looking creatures of the Triassic were the Trypanosaurs. These small, arboreal reptiles had a body plan that was a medley of different animals. They had a chameleon-like grasping head and hands, a bird-like beak, and a powerful, prehensile tail that was likely used to grab branches. Their bodies were short and stocky, suggesting a lifestyle dedicated to climbing trees. Their unique body plan was a product of the sudden availability of a rich, untapped niche, the tree canopy. The Trypanosaurs were an example of a lineage that experimented with a hyper-specialized arboreal lifestyle. The Tanystropheus, the long-necked mystery. The Tanystropheus was another triumph of anatomical strangeness. This reptile is famous for its preposterously long neck, which was over 3 times the length of its torso. While its entire body was only about 5 meters long, its neck alone was nearly 3 meters. The neck was supported by a series of elongated cervical vertebrae, but it was surprisingly rigid. Paleontologists believe that this creature lived near the water, using its exceptionally long neck as a fishing rod. It could snap its head forward from a concealed position on the shore or in shallow water, snatching fish, without disturbing its body. The Tanystropheus's body was a unique solution to the problem of hunting fish from a stationary position, a niche that no other animal had ever filled in this particular way. The Triassic-Jurassic extinction, the final act. Just as the Triassic began with a mass extinction, it ended with another one. Around 201 million years ago, a new wave of massive volcanic eruptions began. This time, the volcanism was associated with the breakup of Pangaea, forming a massive igneous province known as the Central Atlantic Magmatic Province, CAMP. The CAMP eruptions released enormous amounts of CO2 and other gases, leading to another episode of rapid global warming and ocean acidification. This event, known as the Triassic-Jurassic extinction, was less severe than the Great Dying, but it was still a major catastrophe. It wiped out about half of all species, including many of the weird and wonderful reptiles that had defined the Triassic. The Aetosaur, phytosaurs, and many other large archosaurs vanished from the fossil record. However, a few key groups of animals survived and thrived. These included the true crocodiles, which were small and amphibious at the time, and the dinosaurs. The dinosaurs, which had been a relatively minor group of small to medium-sized reptiles throughout the Triassic, were now presented with the same opportunity their ancestors had 50 million years before. With their main competitors gone, they underwent their own spectacular adaptive radiation, filling the empty niches left by their extinct rivals. This event marked the true beginning of the Age of Dinosaurs, setting the stage for their 135 million-year reign over the planet. The Triassic period was a unique and pivotal chapter in Earth's story. It was a time of immense challenge and unparalleled opportunity. The bizarre animals of this era were not just evolutionary curiosities. They were the living legacy of a planetary-scale reset. Shaped by the devastation of the Great Dying and the intense pressures of a Pangaean world, they were nature's first drafts for a new era. While many of their strange forms proved to be evolutionary dead ends, they laid the foundation for the next great chapter of life on Earth, proving that from the ashes of one world, a whole new one can emerge.